All right, guys, so we got more properties of logarithms, kind of like we did on yesterday, but it's had a bit different going backwards. So here we go. Only 2 slides today. The first one says condense the expressions. So yesterday we took expressions and expanded them. Now we're going to go backwards and condense them. So we're going to try to make them into one log. So starting off with more than one, trying to make it one. So remember the number in the front is really the exponent. So I'm going to raise 4 to the third power, which is 64. Plus log base 7, 6. And also remember, when you see addition of logs, that means multiplication. So I'm going to finish up by saying log base 7 of 64 times 6, which I'm about to punch it in my calculator if you can hear the noise in the background. 64 times 6 is 384. So log base 7 of 384. And that's all you do, just convert 2 logs into 1. Okay, do the same thing on natural logs. This one and the second one has a 2, which represents the exponent on the x. Also, this one has a subtraction, which means we're going to divide. So I'm going to divide the 12 by the x squared, and there you have it. So all we're doing is taking 2 or 3 logs and making them into one log. So let's do this last one down here. I always do the exponents first. That 2 is really the exponent on the 3, so it'd be 3 squared, which is 9. That 5 is the exponent on the 2, which is 2 to the 5th, which is 32. And I have just natural log of 8 at the end. Now, the first thing I see now is I've got 2 logs added together, which means I'm going to multiply 9 times 32 because addition means multiplication. So I have natural log 288 minus log 8. And to finish up, I'm going to divide 288 divided by 8 because I have a minus sign, and I get natural log of 36. So all you're trying to do is take more than one log, a big expression, and turn it into just one log if possible, which is what we just did. And the last thing today is change a base formula. This is a really cool thing. You can change the base of any log you want to any base you want to, which means usually we change our bases to base 10 or base e because our calculator does those. So here's what the change of base formula says. Log base a over of b. I got those backwards actually. Sorry about that. Don't read that. It's really log b over log a. The base stays on the bottom. That's how you can remember it. The base stays on the bottom. The base stays on the bottom. So this next one, if I see log base 3 of 8, no, we usually can't work that out because there's no power that you can raise 3 to get 8. So what we're going to do is we're going to change the base to base 10. So I'm going to do log base 8 over log, not base 8, but log 8 over log 3. Sorry about that. Base 10 struggled on this slide. And just punch in your calculator. Log 8 divided by log 3, and I get 1.8927. Actually 2.8. They rush around to 4 decimal places usually. Now, cool thing is you can change any base you want to. If I want to do ln right there and do ln 8 over ln 3, I would still get the exact same answer. And again, the reason we usually use base 10 or base e is because that's what our calculator does so well. There are times, though, when it's good to change the other bases, and I'll show you those when that happens. But for now, that should be good. Sorry about the screw up here. Everything else should be good to go. I'll see you in class tomorrow. See you then.